Okay. I want you to notice my little italicized note that says notice. Okay. Notice in the standard form of the equation of an ellipse that we have two fractions added together and they're both set equal to 1. If you see that happening, that's either going to be an ellipse or a hyperbola, but today we're learning about ellipses. All right? In the numerator of this first fraction, you see x minus h squared. What does that remind you of?
Parabolas.
Circles. All right, well, parabolas too, but when you look at the whole thing together. Circles, right? You remember in a circle we had x minus h, and what did h represent? No.
H represents
The x coordinate of the center. The x coordinate of the center. And then we had y minus k, where k represented the y coordinate of the center. All right? So that's still the same thing. H is still the x coordinate of the center. K is still the y coordinate of the center. All right? Notice when this ellipse is horizontal and the horizontal axis is your major axis, which letter comes first? X. Now what you need to understand is that all things in this fraction pertain to your major axis. Because if my major axis is the x-axis, then my x and x coordinate go here. And A is the distance from the center to the edge of the major axis, so that also goes in here. The second fraction deals with all things from the minor axis. In this case, my shorter axis is the y-axis. So the y coordinate of the vertex, and B, which is the distance from the center to the edge of the minor axis, all go together.
So the y-axis was your major axis?
Yes, and I'm going to show you that in a second. Okay, but you are exactly correct. All right. Yes.
Okay, so if y comes first, what would the equation look like?
I'm going to show you on the next slide, but I want to finish this one first. Okay. The foci, remember there are two of them. Now if the foci always lie on the major axis, listen to me now. If the foci always lie on the major axis, and C is the distance from zero, or from the center, then we're going to add C to the coordinate that corresponds to the major axis. All right? What was H representing? The x coordinate. What's the major axis? The x-axis. So I am adjusting the x coordinate because the major axis is the x-axis. I'm going to first add C to the x coordinate of the center. Then why would I subtract it from the x coordinate? To go back in the other direction. Because the foci are perfectly centered around the center of this ellipse. Okay? Now we already said this earlier. All right. The length of the major axis. We've already said this. If A is the distance from here to here, then what's this whole thing? 2 times A. Right? If A is the distance from the center to the edge, then the whole thing is 2A. So 2a is the length of the major axis. If b represents the distance from the center to the edge of the minor axis, then how could we call or say the length is of the whole thing?
2b.
2b. All right? 2a represents the length of the major axis, and 2b represents the length of the minor axis. Yes, ma'am.
Can you send Joshua Floyd to the office? He's being checked out.
Okay.
Thank you.
So wait, what?
You've got no reprieve.
What signifies that it's 2 units?
It's not 2 units, it's 2 times b units. If b is 5, then it's 2 times 5 units. So 10. Because you're going to go 5 one way and 5 the other. So altogether,
Oh. So
that's
like,
10.
It's like a formula.
Right. Exactly. See you later, alligator.
So it's whatever,
You got some
whatever
problem.
A is times 2, that's how many units. Because that's what both directions.
Exactly. All right. Let me ask y'all something. Pay attention real quick. Let's just think. The major axis. If you know the 2 endpoints, where is the center of the ellipse in reference to the endpoints of the major axis?
In between.
In the middle. What formula have we learned that finds us in the middle? Midpoint.
Midpoint.
In reference to the 2 endpoints of the minor axis, where is the center? In the middle. In reference to the 2 foci, where is the center? In the middle. So if you know endpoints of something but you don't know the center, could you find it? Yes, using the midpoint formula. Okay, now the question was, what if it's not horizontal? What if it's vertical? Well, this is what happens. And you don't have to redraw it, but you can just say if it's vertical, and then you can write the changes down. Okay? But notice, my major axis is now the y-axis. My foci now sit on the y-axis, because that's the major. C still represents the distance from one focus to the center. A is still the distance from the edge of one side of the major axis to the center. And B is still the distance from the center to the edge of the minor axis.
What is H and K?
H and K are the center of my circle, the X and Y coordinates of my center.
That'll be given to you.
Right. Now notice the formula. What comes first this time?
But they stay with the same denominator?
Yes, because remember, this whole fraction pertains to the major axis. And A is the distance to the major axis.
So why would you? Why is that over the distance to? So why is the y? The y comes first, like that's the major axis. Why is it over A? Why is it over the distance?
It is derived from the Pythagorean theorem. Very confusingly and complicatedly. But that's why this formula works out like it does. Okay, so let's just stick with the formula and go how it's used. So this time y comes first because it's the y-axis that is my major axis. My foci now, instead of adjusting the x-coordinate of the center, what am I adjusting? The y-coordinate of the center. The length of the major axis is still 2a units long, and the length of the minor axis is still 2b units long. And so next what we're going to do is we're going to apply. And like I said, I don't want you to get all caught up in all this h comma k plus c, h comma k minus c, all this other stuff, okay? We need to remember that the major axis determines which letter we write